Hi, this is Mark Knutson. We are on video number 4 out of 5, looking at how to use baseband link feature from Matlab Cockpit to completely control SystemVue. And we're on, again, video number 4. And on this example, it's our second beamforming example. We're going to dive a little bit deeper, change the configuration around a little bit. Instead, in the previous videos, beamforming example, Matlab controlled, generated a modulated source. And then we looked at an output spectrum using a Matlab baseband link source. And then we post-process the antenna pattern, gain, theta, phi grid from the SystemVue results. This time we're going to do things a little bit differently. In this example, we're going to generate the modulated signal from SystemVue this time. So there's no baseband link source this time. It's coming internally from SystemVue source. And then we're going to capture the antenna pattern live with baseband link sources that we have to kind of prepare the data before we send it to that. We're going to show you how we do that. And so you could compute the antenna pattern live in Matlab if you want, or you can also do it via post-process ADX file as we did before. So this example is going to have like 3 sinks, baseband link sinks, and no baseband link source. And we're going to see how that changes the code in Matlab to run it. All right, so this is the example 2 that we're working from Knowledge Center. As before, you can download everything from this example that we're gonna walk over today, and it's got a good summary, kind of breaks down what we're gonna do. And I've loaded up the example here. As before in the previous videos, you've learned that run from Matlab is a parameter that we pass in from Matlab, and it's set as the it's set like as an equation controlled part of some of the parts, not all the parts. Some of them are just on, but certain ones are controlled by run from Matlab. So we can tell it precisely how we want it to behave when MATLAB's in control. When you change run from Matlab to 1, that's when MATLAB's in control. You see, we're not using any baseband link source this time. We're switching from a CW source to just a 16 QAM source from SystemVue. So I could delete these two if I wanted to. But I'm not using them at all. I'm doing my beamforming. I'm splitting the phase shifter, the tapering, the beam weights are synthesized, generated based upon beam theta, beam phi that we pass in from Matlab. And you also notice in Matlab mode, I'm not using the sync to get the far field voltage spectrum like I did before in the previous videos. I'm not using that at all. I could delete that also. Basically, in this case, what I wanted to do is, watch, if I go from 0, when I'm in standalone SystemVue mode, I'm just capturing the out of the output of the beam pattern part, the gain, theta, phi grid. And if I, in Matlab mode, I have to basically, I want to capture those live and say I want to process the antenna pattern live in Matlab. This is how I'd have to do it. I have to use an unpack because what's coming out of here is basically a 361 by 181 matrix. Baseband link kind of likes array vectors right now, so I have to unpack it and send it as arrays to the baseband link part, so I can get my antenna baseband, my theta baseband, and my phi baseband. So that's kind of the difference there from what we did before. Otherwise, it's very similar. So it's 3 baseband link sinks, no baseband link source, but it's a SystemVue source for the modulation and a bunch of other SystemVue sinks if we want that data, like the antenna gain, theta grid, phi grid. Like before, we could process the antenna pattern live in Matlab or from an ADX file. And that's what we're going to do in this example. So we set theta to 30. If we run this simulation, we can look at the directivity, and we'll come back to these and we can compare them later, but it's at minus 30, minus 19, minus 13, etc. We'll come back. You can check the phi matrix. It's a lot of data there. So why do we have to use the unpack? Let's look at that in Matlab. So in Matlab, like Y1, I'm going to capture the data at a sink. We'll come back to this in a sec. We'll go over this code in a little more detail, but Y1 is the sink. That's coming in at 36531 by 1, 65,341 by 1 double. And so if you compare the antenna gain versus basically this antenna BB, the antenna gain, if we look there, so let's run that again. It's on the wrong one. All right, let me run the right design here. If we look at the end, I think what I did is I left this on baseband link. Okay, let's try that again. Don't make that mistake. So I want to make sure I have it in standalone mode. So if I run this, get that. And if I look at the antenna gain, it's basically a 1 by 361 by 181. So that is why we use an unpack to unpack in column major fashion 361 by 181 to give it a block size, an array of 65,331. That is how this baseband link sync is set up to pass things to Matlab, and it comes in as a double. And then you're going to see, I'll just jump to the end and then we'll come back and look at the original code at the top. But kind of the punchline here is that's why the Y1 comes in as this double and I reshape it in line 94 by 361 by 181. And then I can compare that against the directivity, which is that sync in antenna gain becomes a directivity, and I compare that against antenna BB, which is Y1, Y1, right? And is reshaped as Y antenna. So I'm going to compare Y antenna and directivity, which comes from my antenna gain. So that's what we're going to look at in a sec here. But let's look at the code real quick and see how that's done. If you watch the other videos, it'll go through a lot of the detail here on how this was built. But let's just go right to the Matlab code. And so here we go. If we set beam theta to 30, let's set it to 30, not 45 as I heard. If I have set that to 30, this is what we're going to see in Matlab here. So we set beam theta to 30, sample rate, carrier frequency passed in as parameters at the schematic level. We open the workspace, which we have here, target workspace, example 2 workspace, and we set the parameters that we pass in on the parameter schematic level, carrier, sample rate, block size. And we set up some containers. Y1 through Y3 is what we really need because we have 3 baseband syncs. We saw before that that's where we have the code to, oops, That's where we have the code for antenna baseband, theta baseband, and phi baseband. And so we're basically attaching sync 1, 2, and 3 to those instances on the schematic. We start the simulation. Look how much simpler this is than the previous example one. We just grab the data. There's no baseband source. It's an internal SystemVue 16 QAM source. And so we just basically use the getData function for each of those syncs. And then we basically grab the data, stop it, close the workspace. We get we take Y1, Y2, Y3, which are those big 65 through 41 by 1 double, basically big arrays of double data, and we reshape it into the matrix form to compare it against SystemVue the way we expect. So I have Y antenna, Y theta, Y phi using the reshape function, and then we can post-process the data. Again, it's these syncs that antenna gain, theta grid, phi grid, and we're going to grab that from the ADX file and reshape those, squeeze those to get rid of that extra 1 by what in the matrix in SystemVue that we don't need, so we use the squeeze function. And so now we can compare phi matrix, theta matrix directivity against Y antenna, Y theta, Y phi. And if we do that at 30 degrees theta, we see minus 30, minus 19, as we saw. This is what we see in Matlab, and that's what we saw earlier in SystemVue at beam theta 30. Now let's see what happens when we switch to beam theta 45. So by the way, before we close this out, if I plot the beam, so I can do that in a few lines of code in SystemVue. If I plot, this is at 30, so that's at 30. So if I delete that, and if I go back to my schematic, and if I change this to 45, run this simulation, plot the pattern. Now it should be at 45, add a peak marker. Yep, beam theta 45. So I should get similar directivity, right? Now it's minus 12, minus 10, minus 8.7. So if I run this in Matlab, it's very fast. We get all the data, and if I compare like the Y antenna, I guess I already have it here. See, it's minus 12, minus 10, minus 8, as we expected. And all right, if I go back and I do the directivity, we'll see the same. So hopefully that you find that useful. Basically, changing to the 45 degrees, we see what we expect on the directivity and the phi matrix and the theta matrix. All right, last video is the next one coming up, so look forward to seeing you for that. And we're going to do one more thing and play around with a different scenario between baseband source and sync and how that changes the MATLAB code. See you next time.